Let's work through a couple of example cases together so we can get the hang of how to use the Coagulation Ys to figure out the answer to problems with hemostasis. The first case is that we did the bleeding time test in a dog and it was increased. We looked on the CBC and we saw that there was a marked decrease in platelets. We found out that ACT, which also assesses the intrinsic factor pathway, was increased. But activated partial thromboplastin time was normal, PT was normal, and thrombin was normal. Because all of these were normal, we know that it's not a problem with secondary hemostasis. It is a problem of primary hemostasis, and that is because there just weren't enough platelets to make to fix the defect in the buccal-mucosal of the dog. But why would ACT be increased? We haven't talked about that, activated clotting time test. It's a highly insensitive test. Recall that we talked about what we add to various test tubes. We add tissue factor to this one and calcium. We add partial thromboplastin to this one, just the phospholipids, and calcium to this one. We add activated thrombin to this one. To activated clotting time, it contains diatomaceous earth or something else that is attractive to starting clot formation, but it doesn't contain any phospholipid substrate. In the activated clotting time test, the phospholipids come from platelets already present in the sample. So if an animal is thrombocytopenic, they will have an increase in ACT sometimes. The next case we have is one that has normal bleeding time test. So that means that platelets are adequate in number. That means subendothelial collagen is fine. That means von Willebrand's factor is fine. That means there's an absence of vasculitis or an absence of a congenital defect in platelet function. Platelet count was normal. The APTT was prolonged. So partial thromboplastin, calcium added to the tube, and a clot took a long time to form. But PT was normal, so was thrombin. Because this was normal, and indeed this was normal, that means that the problem is not in the extrinsic factor or the common factor pathway. That means that the problem must be up here. And that would be most consistent with hemophilia A with a deficiency or defect in factor 8 and then factor 9. These others are less commonly involved in coagulation factor problems. And if we suspected that we had a problem in one of these other things, we would have to send it away to somebody who researches very specifically those particular factors to find out which factor was defective. The next one, in a simplified view, we have an increase in bleeding time. On the CBC, we identify a mild decrease in platelets. We find that ACT, APTT, PT, and thrombin time are abnormal. Well, we know we have a deficiency in platelets, so that's problematic. And then we have problems in all three of our test tubes. They are not forming a clot in an adequate amount of time. What ties all of these and primary hemostasis together? Yes, in the simplified view, it would be the consumptive phase of DIC, or disseminated intravascular coagulation. The next case, if we have a normal bleeding time, we have normal platelet count, we have no problem with the ACT tube, and we have no problem with the thrombin time tube, but this is prolonged. Well, if I cover that up because this is all adequate, that's adequate, then the problem is isolated to factor 7. And factor 7 deficiency or defect is possible, but the most common time we would see that is with an anticoagulant rodenticide like warfarin. because factor VII has the shortest half-life, it is consumed first. So in the early stages of rodenticide poisoning, then we can see an increase in the PT. So I hope you find some of these cases helpful and how we manipulate the coagulation Ys so that we can understand how to work through data that we get from the laboratory regarding coagulation.